In the first video, we have seen how we imported the TensorFlow, we imported the sequential package, we imported the dense for building the layers, we imported NumPy for computations, we imported Matplotlib for plotting, we approximated the function sine pi x over n within the boundaries minus a to a. We used 100 divisions, and this is how we created 100 divisions. We set some y, which is going to be the target, as sine x, and then we plotted to see our function first before building the model. And in the first model, we build the sequential model, and here we build the first layer with 30 neurons. We have 30 neurons here, and so I guess I'm supposed to. We have 30 neurons here. Input shape is 1. It's number of samples by features. So number of sample is 1. So that's 1 is coming in. This is very important because if we begin to apply the window method, you will see that here will not be 1, it's going to be the window. Here we chose an activation function, tan hyperbolic. We can change it. We were seeking one output. We compiled the model. We fit the model. So these are the basic steps. Call the package, build the input layer, then build all other layers if you would like, and then finally the output layer. Then compile the model, and then fit the model. To get forecast or prediction, all you have to do is model.predict. Then we compared here our model outcome, which is this one, with the real one. And now we want to move to method 2. In method 2, we would like to, let's copy all of this. Let's copy all of this. Control C. In method 2, we would like to build a different, we would like to train the model in a different way. Let's say we have all this, but in this case, we need a window. A window, let's say window of 5. Let me explain window. Window is like this. If x was 1, 2, 3, 4, 5, 6, if you window this data, if window is 2, for example, then 1, 2, then 2, you get the idea. 2, 3, then 3, 4, then 4, 5. This is how, then 5, 6, then 5, 6. This is window. In the previous training, in the other video, we give it 1 and ask it to predict y. We then give it 2. We ask it to predict y. We then give it 3. We ask it to predict y. We then give it 4. We ask it to predict y. But it turns out that if you could give the model some sequence prior, let's say you can tell the model that, okay, when you see 1 and 2, then you can give the prediction of y, which follows 1 and 2. And if you see 2 and 3, then the target, so here, let's say x, so when x is 1 and 2, let's assume y of 1 and 2, the next one will be, because the idea of neural network is is trying to predict the next in the sequence, right? The next output. What will be the next output? So if it sees 1 and 2, it might want to predict, let's assume, okay, so let's assume y is 3, 4, 5, 6, 7, for example. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let's say 8, for example. So if it sees 1, 2, it will predict the third one. If it sees 2, 3, it will predict the fourth one. And then if it sees 3, 4, it will predict the fifth one. And on and on and on. I hope you understand. And that's what we want to do. So for us to be able to do this, we first have to choose the window. And the window, in fact, I will explain this more in another video, the mathematics. But for now, you can create the window this way. You can call x window equals, and then y window equals. And then you can say for I in range, here you have to say len x minus window, because it will keep going. So x window dot append, it will append x of I to I plus window. And then for y will be the I plus windowed, so y window dot append y of I plus window. So the x will run from I to I plus window minus 1. And then this will be the next. Just like the one I say, when your window is 2, then 1, 2, then 3. Okay. So that's what we get. Now, we also need to make these guys numpy arrays. So xw equals np.array xw, and yw equals np.array yw. Now we can build the model. Easy. md2 equals sequential. That's the package. Now we add the neurons. md2 dot add a dense layer, the input. Now the neurons, let's choose maybe 40 this time around. Input shape. Here the input shape will change because now the input shape is window, and the activation is tan hyperbolic. Then we close. Next, we add the output layer. You may add, okay, so let's assume we would like to add some inner layer. So md2 dot add dense. Let's add some dense layer with maybe 3 or 30. This time you don't need the input because it will accept whatever comes to it, but it will have 30 neurons. So all the 40 neurons here would be given to these 30 neurons, and but you have to activate the output. So activation, just like we explained. Let's apply the same activation. Let's say now we want the output layer. So we have input layer, hidden layer, now output layer. The difference between input and output and hidden: input will have input shape. Hidden layer will have only activation and the number of neurons and the other things you might want to, if you want to adjust the weights or something. Output layer has no activation function. So md2 dot add dense with 1 neuron. So output layer, you only give the number of neurons you would like to have. So this one has 40, and this one will collect, it's like all the 40 will give each one, so it's like 40 times some kind of permutation, and then here you have one outcome. Now that's the model, and we compile it. md2 compile, choose your optimizer. Adam optimizer is popular. There are other optimizers you can use. And the loss function, the one we used in the example, mean square error, you can run. We have a situation here. Oh, window is not defined. Oh yeah, so I have to run this and then run this. Window, okay, input shape. All right, input shape window. It says input shape not defined. Oh yeah, we need to have some equality sign here. Good. Now it run. Yeah, so we compile and then we fit. So model dot fit x window, y window, epochs. You can choose, I like 1000. Verbose, we already know what it means. You want to see the outcomes, or you want it to just run, equals 0. Then we run. Before it's done running, we try to make prediction. So rs results equals md2 dot predict. Let's see how it was able to predict the x. All right. Oh, sorry, x window. Yeah. Now let's plot plt dot figure, fig size equals 15 by 3, and plt.plot x comma y. We plot xy first. All right, so this time we have to, anyways, you can see, I think. Then now we plot, so plt.plot here we are going to plot x, because the first 5 predictions until window there will be no the first 5 will have no predictions, because the first it begins from the first 5. So from window above, so window above comma rs2, but you have to suppress. You have to suppress because it will, it's a two. This RS is a 5 by 1 array, so it's, anyways, we oh no, it's not RS2, it's RS. Good. So what do we see here? The machine has learned better. You see, it's even better here. No need for labeling which one is which. You can see one is orange color, the other one is blue. Whereas in the first one, you see they did not, even though we trained for 1000 epochs here using method 1, the direct method, and the window method, we also used 1000. So it seems like for sequential modeling, especially time series, let's say you're measuring temperature, you're modeling, you want the model to learn temperature, and you may want to use the window method. In fact, it's really important. There is also another training method called the zigzag method, and you train in a zigzag way, lots of other, but I think with those two examples, inshallah, everything is clear now.